So today we're going to talk about simplifying complex fractions. So first of all, you might be wondering, what is a complex fraction? A complex fraction is a fraction in a fraction. So as an example, if I gave you guys something like that, that would be an example of a complex fraction because you have a fraction inside of another fraction, if you will. So that's what a complex fraction is. Today we're going to be simplifying those. Of course, we're going to be doing it with variables and stuff because we're dealing with rational expressions. But okay. Let's go ahead and write this one down. We'll call it example 1. The directions are simply going to be to simplify. All right, so the first thing I'm going to do is I'm going to rewrite this as a division problem. You do top divided by bottom. So I have 9 over x squared is the top part of the fraction, and we're dividing that by the bottom, which is 4/9. So that's all a fraction is anyway. When you guys have a fraction, it's really just you're dividing the top number by the bottom number. So I'm just changing the way it looks. But now that I've changed the way it looks, hopefully that kind of triggers for you guys something that we've learned before, which is to do keep, change, flip. Keep, change, flip. So that would be keep the first fraction the same, change the division into multiplication, and flip this second fraction over. At this point, you want to see if you can reduce anything. Okay. Now, for this particular problem, I don't see anything that cancels out. I've got an x squared on the bottom, but that's not going to cancel any x's on the top. I also have a 4 on the bottom, but that's not going to divide into the numbers on the top. So nothing reduces. So the last thing we're going to do is just multiply together. So 9 times 9 is 81, and that's 4x squared on the bottom. So change it to a division problem, same change, flip, reduce if possible, multiply what's left together. All right. All right, let's do, I'm gonna change this one up a little bit though. I don't like that problem quite as much. Let's do 2 over x. All right, so go ahead and write that one down. We're going to treat this one like a guided practice problem. Call that guided practice number 1. Okay, so I'm going to ask you guys what to do first here. So Niana, what's the first step? That's right. We're going to rewrite it as a division problem. So that would be the top one divided by the bottom one. Miles, what's the next step? Keep, change, flip. So keep the first one, change that to multiplication, and flip this one over. And Haley, what's the next step? See if we can reduce. Now on this one we can reduce. If I have one x here, and I've got two x's here, this one x is going to take one of the x's away here, so it's just going to leave me with 1. And then the 2 divides into the 6 3 times. So on this one we can reduce. And all I'm left with is a 3 on the top and an x on the bottom. And so that's my final answer. Okay? I think I'm going to hold off on this one for a minute. I'm going to change this. Let me call it, there. All right, guys, why don't you try this one real quick? This is your student practice number 1. See how you do with it. All right, so that's simplifying complex fractions there. So now we're going to just take it up a notch. I'll show you the two situations we're going to look at today beyond that. So this one is a complex fraction too, but as you guys can see, it has 3 parts to it. It doesn't have just a top and a bottom. It has a top, but the bottom is 2 things. So now we've got 3 parts to it. So that'll be the first thing we look at. After that, then we'll look at ones that have binomials in them. That kind of makes things a little bit more tricky also. So we'll add 2 layers of difficulty to this as we go. So let's go ahead and call this one here example 2. And let's go ahead and write that one down. So here's a little note that I would encourage you guys to write. If the numerator or denominator has 2 fractions being added or subtracted, we will first add or subtract them. Here's my numerator, here's my denominator. Now the denominator has 2 fractions that are being subtracted. So anytime you have that, what we're going to do is we're going to start by putting those 2 fractions together into one. After we do that, it'll be just like the problems we had before. Okay, so that's the first step. So I'm going to do that off on the side here. We have 25 over 4 minus 1 over x. Now, do you guys see something I can do before I start trying to get a common denominator here? Oh, wait, never mind. I thought maybe this could be reduced, but it can't. Never mind. But if you can reduce them first, but it doesn't reduce. I thought maybe it did. My bad. All right, I want to subtract these. So to subtract them, we need a common denominator. So what will I multiply this side by? And what will I multiply this side by? There you go. And then we're going to go ahead and combine those tops together now into one fraction. That'll be 25x minus 4 over 4x. So when you're dealing with complex fractions, if your numerator or your denominator has two fractions that are being added or subtracted, we're going to start by putting those together by getting a common denominator and combining them. Okay, so now I'm going to replace this bottom with what we got over there. The bottom is 25x minus 4 over 4x. After that, we're just going to do what we did before. We do top divided by bottom. So top divided by the bottom. And then we do same change flip. So we're going to keep the first one the same. Oops. And then we're going to change the division into multiplication, and then we're going to flip this other fraction over. And you guys remember what to do about this situation when it's not a fraction? What do we do there? Just put a 1 under it. Not a big deal. All right. So we got the two fractions together into one. Then we just do the other steps we did before. Rewrite it. Keep change flip. See if you can reduce, but nothing's going to reduce here. So we'll skip that. And we're good just to multiply straight across. X times 4x is 4x squared. For this, I'm going to show the work. It's kind of unnecessary, but I'm going to put these next to each other like that. And I want you guys to understand, anytime you have a binomial, you're going to have to distribute. Now, when you multiply by 1, it's not going to change anything. So I wouldn't usually write that step because it's kind of pointless if it's a 1. But I do want you guys to be aware that you're going to have to distribute in those cases. And there's our final answer for that one. So notice all the steps were the same except for the first one where I combined those two fractions together into one. Okay? No, no. If it was a negative one, it would, but it's not. All right, let's go ahead and try a guided practice with that. So go ahead and write down this example here. So the first thing we want to do is get a common denominator. Now, all you need to do is multiply this side by an x to get your common denominator. That's all you need to do. So we have 16 over x squared minus 1x over x squared. And we can't combine those, but we can just put a minus between them like that. So let's be 16 minus x. Okay. So that's the first step. All right, and that's the new step. The rest of it's the old one. So Damione, what do we do next? Rewrite it. So we're going to do 16 minus x over x squared divided by 1/4. And then Cynthia, what's next? What's that? So we have division here, but we have to do something at this step. And so what do we need to do the division? Replace the bottom? No. Here's what we're, yeah, there you go. So we're gonna do same change flip. So it's gonna be 16 minus x over x squared. Keep, change, flip. All right. Go ahead and see if you guys can get the final outcome there. I'll ask you what you got. So that one was a little bit more challenging. Got to remember how to combine your like terms or your fractions, right? Getting a common denominator. Okay. And then after that, all the steps are about the same. Let's see how you guys do with the practice problem though. Try this one out. Do another one. But there's our final answer. So I think people had trouble getting the common denominator in the beginning. That's okay. That's like our new step. But also getting those things backwards, right? So try not to get those things backwards this time. I'm going to let you guys try one more like that before we level it up. Try one more like that. I won't give you quite as long this time, though. But go ahead and just do what you can. All right. Go ahead and write that one down. This is example 3, yeah. Okay, so the only thing that makes this one a little bit more tedious is the binomials are going to make a little bit more work for us this time. Here we go. Once again, my numerator has two things that are being added or subtracted, so I want to put those together first. So let's do that. I'm going to do x plus 1 over x squared. So to get these together, they need a common denominator. So I'm going to multiply this one by x plus 1. And I'm going to multiply this side, I'll put these in parentheses, by x squared. So I'm getting a common denominator there, right? All right, so on the bottom I've got x times x plus 1, x squared, I mean. On the top right, x squared times x squared is x to the 4th. How do I do this? This is the part that's kind of new for this problem. How do we do it? The box method. So if you have two binomials being multiplied, you got to do the box method. So x plus 1 times x plus 1. We have x squared. We have 1x plus 1x, which is 2x. And then we have 1. So I use the box to find that one there. We could put these together now into one fraction. There's no like terms to combine. And now I've simplified the top. The top is now this. So that's what makes this problem hard, was that step there, okay? And what makes that step hard there was just the fact that we couldn't just do the math mentally. We had to go off on the side and do the box method to actually multiply it. So don't be surprised if that pops up in there as well. But after that, it's all pretty much the same. It looks uglier, but there's no new steps to it. So am I good to erase this here? No objections? Okay, so we do top divided by bottom, right? So this comes first, and then this. Top divided by bottom. And then we do keep, change, flip, right? So keep, change, flip. You guys see anything that we can reduce this time? Yep. Now, these ones have pluses, right? Well, so long as you cancel out that whole thing, that's okay. That's all one big factor. So yeah, these can cancel out completely. And so I'm left with x squared plus 2x minus, plus 1 minus x to the fourth over 2x squared. So yeah, it's a lot more there this time. But really the only difference was the box method was required for multiplication. The rest of it was all the same. The rest of it was all the same. It looks burdensome, but it was really just a box method issue. All right, and that's where we'll